Alright, now we're going to talk about different termination types for our work area outlet, our twisted pair of cabling work area outlets, if you will. The two different types of termination we have are screw type and insulation displacement connector, or IDC. The first one, screw type terminals, as we mentioned a little bit ago. This was how phone wires and everything got terminated. Very common, very good electrical and mechanical connection. But by today's network bandwidths and network speeds, there's too much wire and twist in here to terminate that. There's too much wire and twist, which causes, or I should say, gets rid of the cancellation, which allows for crosstalk and other interference to creep into our data network. So, screw type termination was acceptable for phone and early data, but not by today's standards. So, we don't use screw type termination anymore. We actually use the insulation displacement connector, IDC. Our RJ45s that we terminate patch cables use IDC, and our outlet jacks that we're going to terminate use IDC termination as well. And what's going to happen here is, as I push the wire into the jack or take my RJ45 and crimp it on top of my wire, there is some mechanism that's going to cut through the insulation and make contact with the wire inside. Hence the name insulation displacement. I'm cutting away some insulation to make contact with the copper wire inside. And the three main types we run into are 66, 110, and our snap-in that we're going to deal with, if you will. So let's take a look at those real quick. Insulation displacement connector, I'm just reminding you here, as the wire gets laid into a jack, what's happening is a punch down or a tool is forcing the wire down in, and as it gets forced into place, there's some kind of metal V here that's cutting away the insulation and making contact with a copper wire inside. That's the term insulation displacement connector. That's the kind of thing that is occurring. If I look at a 66 block for telephone networks, telephone systems, what I have is, here's my 66 block. As I look a little closer, there's actually a series of metal V's that when I lay the wire in and use a punch down, it's forcing the wire down in the metal V, cutting the insulation and making contact with the wire inside. So phone systems or phone blocks that's used a 66 block, that's an insulation displacement connector. The 110 block that we talked about earlier this semester uses insulation displacement connector. If I look a little closer, if you remember, I lay the wires into this frame and I snap this 110 connecting block on top. Well, on the back of this 110 connecting block, you'll see that there's little metal V's that as it snaps on top of those wires, the metal V's are cutting the insulation away, making contact with the wire inside. And actually, if I were to zoom in on this part here, I would see metal V's as well. Well, we still see this today and still use this today because on the back of a patch panel, if I look down in there, there's metal V's that as I force the wire in, as I punch the wire in, the metal V is cutting away the insulation, making contact with the wire inside. So in our patch panels that we're using actually use this insulation displacement. Well, as I start looking closer at my outlet jacks, I see the same thing. As I look at a snap-in style outlet jack, as I pull the cover off and look underneath, there's a series of metal V's that when I lay the wires in place and push the face plate down on top, put this little, I should say the little plate, the color-coded plate on top, the color-coded plate is pushing the wires down into the metal V's. The metal V's are cutting the insulation, making contact with wire inside. So our outlet jacks are using this, and as I keep looking, here's another style outlet jack that uses it. Down in there's metal V's. Here's another style outlet jack. As I take off the cover, metal V's. If I look at my RJ45, which we did before and we will again soon, these metal V's that are here, as I crimp them in the crimper, the metal V's are getting forced into the wire and cutting through the insulation. These are all insulation displacement connectors. And the reason we're using these is we do not have a lot of wire untwist when we terminate with this method. Here's a 110 block type outlet jack. The wires come up through the middle and fan out. As they come up through and fan out, there's very little wire untwist in this wire pair. Wires get laid in, I punch them in, and bada bing, bada boom. They're connected, but I don't have a lot of wire untwist to do it. That's the reason we're using this. Well, how would the termination look? Well, if I'm using this type of outlet jack, again, I feed the wires up, and as you'll see, the wire comes in and the pair gets untwisted just enough right here to go down across this color bar, so there's very little wire untwist. Once I feed all the wires into place, I use a punch down tool to punch them into their slot. And as that punch down tool is going in there, it's bang. It's punching the wire down into place, and as the wire is going down through the metal V is cutting the insulation and making contact with the copper wire inside. That's one type of outlet jack that I'd be terminating. This is more like what we're going to do. This style outlet jack, the color-coded cap back here slides off, and as I look, there's metal V's in here. That's the insulation displacement. What's going to happen is I'll feed the wires up through in this case, ours actually look like this, the red part of the jack, the color code part. I feed the wires up through that, put them into their little notches, into their places, and then this slides on the back and gets forced into place. Okay, so there's the red cover. This is going to get slid back on. The wires are coming up through the middle. As I slide this into place, I'm going to use a tool. The tool is going to help to force this back cover into place. Take this back cover and force those wires, force these wires into the metal V's and terminate it. So I often use a termination tool. We actually have, ours actually look very much like that, to put those caps onto our outlet jack. Some manufacturers actually have, a tool that once I feed the jack into it, I actually have a handle that I squeeze that does the forcing together for me, forcing the cap on the back and causing the wires to be cut with the metal V's and make contact with the wire inside, if you will, the insulation displacement. If I look at some other outlet jacks down the road, things like 6A, category 6A, when I start dealing with shielding, you'll notice the outside of the outlet jack is metal. That's going to make contact with the shielding. And as you see in here, it's still insulation displacement. Wires come up through the middle and feed out through these little notches, and as it slides, I will have some kind of tool, like I had here, some kind of tool to force this cap in against those metal V's and cut all the wires. I should say force the wires into the metal V's and make contact, and then these pieces snap closed behind it to hold this in place and have the shielding make contact with the outside of the outlet jack. As we move on to category 7, our outlet jacks are looking different. The style is changing a little bit. They're looking at this kind of style for category 7, so that will be a little bit different critter as we go to deal with that one down the road. So there is our outlet jacks and kind of the screw type and insulation displacement. We're going to be using the insulation displacement, and actually as we terminate our outlets in lab, they're going to look very much like this. That's the style we'll be dealing with. Our wiring patterns for these, well, our 568C standard, we pop over to here. If I look at our 568C0, as I come down in here, 8 position modular jack pinout assignments, page 12. As I look at my page 12, here is the pinouts for our outlet jacks. Okay, eventually you'll need to know them, but for the nice part on our outlet jacks, here's the nice part. I can just follow the color code that's listed here on the outlet jack. If I follow the color code, as I terminate, all the wires up here will be in the correct order. All the pin out here will be in the correct order. That'll be the nice part for us. We can just follow the color code. But when dealing with our outlet jack terminations, the standard specifies 568A, 568B. They are electrically equal. Historically, 568 was unique to the TIA standard. Historically, B was from the AT&T cabling system. Okay, but 568A, or I should say 568C standard says, okay, and new cabling, try to use the A standard. That way we're kind of getting everything standard, if you will, in the whole building, but they are electrically equal. For the most part, whatever you have in your building, keep with that standard and keep using it. That'll keep things consistent. And here we go. We're just kind of reminding you of the same thing. Official stance is TIA says you should be using the A color code on new installs, but keep standard. If you're doing new installs, do A, but if your building is using B, then stick with B the whole way through. And then here is the pinouts. 1 to 8, if you will, in the color code. Eventually, we'll need to know them. As we start terminating, start paying attention, it'll be easier to learn them. I have a couple different formats here, whatever seems to work for you. Okay, before we move on to anything else, as we finish up our twisted pair, they remind us about categories. And they say, okay, if you're using category 5E cabling, everything in your system should be 5E. So I'm going to point out to you that as I start dealing with this, here's another thought. Your system is always strong as the weakest link. So as I start dealing with cable installs, if you have category 5E the whole way through, category 5E horizontal cabling, category 5E patch panel, category 5E patch, outlet jack, my patch cable should be 5E. But people start saying, well, I'm using category 6 patch cables. It don't matter. Your whole system is only going to be as strong as 5E. The system is only as strong as the weakest link. So changing one part really does not do anything valuable. In some cases, it can actually cause micro reflections and other problems in there. It really only is as strong as the weakest link. So to remind you here, as I'm dealing with this, your whole system should match. If I'm going to use category 6, it should be category 6 cabling, category 6 outlet jacks, category 6 patch panels, category 6 patch cables. The whole system should be the same category. So as I start looking at my components, I will start seeing everything's labeled. Outlet jacks say 5E, outlet jacks say 6, outlet jacks say 6A. They are labeled. You need to look for it. Patch panels are the same way. Patch panel category 5, category 5E. They're labeled. Look for it. Category 6, category 6A. Look for it. Your whole system should be matched. Your whole system should be matched. Here's some patch cables, category 5. Okay, your whole system should be matched the whole way through. Horizontal cabling, outlet jack, patch panel, patch cables should all be the same category rating. All right, as we come back, we'll talk fiber optic outlets.